All right, Brad. I think we're ready to go. Whenever you'd like to get started, go ahead. Sorry, you're muted, by the way.
There we go. Hi, welcome to my clustering project, which focuses on the Zillow data set. The purpose of this project was to use clustering methodologies to identify what features contribute to the Zillow log error and try to find a model that produces a more accurate log error. Ultimately, I explored home features such as room count and square footage of the home, and this developed into a linear regression model using polynomial methods at the power of 2, which resulted in a 0.1% better than baseline on the validate set. The test set did 0.5% better than the baseline. And so let me show you kind of how we got there. So I set up the libraries and pulled in data using SQL from the CodeUp SQL database. This resulted in about 77,000 rows that needed processing. Processing consisted of filtering to single family homes, identifying missing rows by data in columns, and either filling or eliminating these rows based on the needs of the data set. Unnecessary and duplicate rows were dropped, and latitude and longitude were adjusted for accuracy, leaving about 62,000 rows of data, which I then did some box plots to create to help identify outliers. And then I used an IQR method with a K of 3, which left about 52,000 rows to align with the rubric. Jumped into the explore phase. I don't want to spend too much time on the different exploration questions, but I looked at specifically 4 questions dealing with data and the log error, finding some statistical significance based on the county, based on the overall on a Pearson's R test, and then I did an ANOVA to compare the different counties. Also found some statistical significance supporting home data, such as the room price and square footage, or room count and square footage. And then because Zillow's definition of log error was focused on price elements, these were kind of the features I focused on during clustering. So looking at clustering, I did 3 different models kind of clustering. First, I looked at the key variables from the EDA. The cluster, I found no statistical significance between these 3 in the log error. So then I kind of moved on to value factors such as tax and land value. I had a 2 of 5 clusters showing statistical significance. However, it kind of presented the best visual of clustering that I've received. Lastly, I moved on to home variables with 4 clusters. 3 of the 4 clusters showed statistical significance compared to the log error, but the visual was still very chaotic. However, since I had the best statistical significance, I used that moving forward in the modeling phase. When it came to modeling, I developed a baseline and used 3 different linear regressions to compare RMSE and R-squared values. The polynomial model at the power of 2 had the lowest RMSE score and the highest R-squared, but it was still kind of very minimal in comparison to the baseline. Using that sample data, I kind of got a 1% or 0.1% better than baseline. And you can kind of see here the difference between that polynomial model of the baseline and then the actual log errors. This led me to do the test phase, which again did a 0.5% better than baseline. And here it is in comparison to the polynomial and predict and the baseline. So you kind of see my little test area in there. My ultimate conclusion was that log error can be improved upon. However, the features that I chose and went with kind of had minimal improvements. And I would suggest that we kind of explore more of the county data and possibly reverse engineer the log error to find drivers of sales price. With that said, that kind of concludes my project. Are there any questions?
Thank you, Brad. Yeah, I have a question. Excellent work, by the way, and thank you for keeping it nice and succinct. So one of the questions I have is that you have a lot of observations in your original data pool. I think you said you had over 70,000. How did you define a single family home? How did you end up with that number?
So I did ultimately a couple of different things. It basically, there's some in there that says single family home, but then there's condominium. Basically, if it housed one family, that's kind of what I went with. I use those different search terms. And if you go into my, I believe my utility.py file, it has the whole list of items that I looked at.
Okay. And then I have another question, but I don't want to steal it from Adam in case he's going to ask something similar. Adam, do you have any questions for Brad?
Yeah, I have one question surrounding the data that you use to form some of your clusters. I'm curious if you're using scaled or unscaled data when you were forming your clusters and why.
So when I was forming the clusters, I did all scaled data. I had intended to go back and look at unscaled data as well, but I wanted to make sure I completed that MVP before I jumped to unscaled data. But everything for the clusters was scaled.
Awesome, thank you.
Cool. Yeah, and I guess the last question that I have is that when looking at your outlier selection method, you said that you were you using some kind of like two keys IQR method, or okay, you did.
Yep, I used the IQR method, and then I kept playing with the K value, so that way I would get to that 52,000 kind of rows, and so I ended up doing a K of 3.0.
Okay,
to limit
and
those outliers.
I think your comment here answered my question. So I was curious if you had removed outliers in latitude and longitude, or if you had limited outlier removal to specific columns. And it looks like you specifically removed outliers in bath, bed, square foot, lot size, and tax value. Is that correct?
Correct.
Just okay. All right. Thank you, Brad. Appreciate it. Okay, it looks like up next we have Jeremy. Jeremy, whenever you're ready, please share your screen and we'll let you know when you can get started. All right, and Adam, you have the timer set? Awesome. Okay, Jeremy, whenever you're ready to go ahead and begin.
Good morning, everybody. My name is Jeremy Lagunas, and this is my Zillow clustering project report. A brief description: I worked with the Zillow data to try to find useful clusters in the data, and then those clusters were used to generate models which predict the log error to see if we can improve upon the baseline log error. My project goals were to generate informative visuals to show how variables interacted with each other, to find which features to use in a predictive model, and to create a model which outperforms the baseline. First, I acquired, prepared, and cleaned the data. All the specific steps of this can be found in the Wrangle file attached. Next, I split the data into my train, validate, and test data sets. Then I moved on to my exploration. From exploration, I just wanted to look at how the log error was affected between the several different variables to see if those could be potentially useful to use in modeling. First, I looked at the different counties and found that Orange County had a higher average log error. Then I moved on to look at the square foot of a house and saw that the larger square foot houses tended to have higher average log errors. Then I moved on to the year built and found the same thing, that newer houses tended to have higher average log errors. And finally, I wanted to look at the number of half baths in a house and found that houses with 2 or more half baths tended to have a higher average log error. And all of my statistical analysis for each of those variables showed that those differences in log error were statistically significant. So this is a brief exploration, summary of my exploration. The variables I looked at were county, square feet, year built, and half baths. And all of those seemed like they could be useful clusters used in clustering to help predict log error. Next, I moved on to the clustering. I generated some dummy variables and made sure my data was scaled. And then I created what I called the house cluster, which contained the square feet, number of bedrooms, and number of bathrooms. And I wanted to see how the log error was different between those clusters, and found that clusters 0 and 1 tended to have higher average log errors than cluster 2. And then I made it one more cluster, which I called the age and size cluster, which consisted of the year built, the square feet, and the lot square feet. And I wanted to see the same thing for the log error, and I saw that the cluster 0 and cluster 2 had a higher average log error than cluster 1. And so I wanted to move on to modeling next, so I created my baseline, which was just the average log error for the trained data set, which generated a root mean squared error for the validate data of about 0.187. I used select k-best to see which features that would suggest using, and it suggested a number of bedrooms, the square feet, both scaled and unscaled. I thought about just trying to manipulate this, but I was running a little short on time. I just decided to use all 4 of these features, even though they were kind of redundant with each other. And I use that as my group 1 features. I used 2 other groups of features, group 2 being the house clusters that I generated, and then group 3 being the age and size clusters that I generated, just to see how those clusters would perform, if they were better or worse than what select k-best suggested. I started off with linear regression, and for that, the group 3 performed better or best. And then I moved on to lasso Lars, and all 3 of those groups ended up performing the same, but they did perform better than the linear regression group 3. So I just decided to move forward with group 1 lasso Lars for the test data set. I used that on the test data set, and it produced the root mean squared error value of 0.167. And for wrapping up my conclusion, the model's performance on the test data ended up outperforming the baseline by about 11%. My exploration consisted of just a few different questions to see how the log error changed with different variables, to see if those would be helpful with clustering and modeling. My recommendation is to implement any lessons learned today for our process for improving log error in the future. And my next steps I would like to take on this project would be to utilize different variables for new clusters and refine the models by changing the hyperparameters and model features. Thank you, and I'm ready for any questions.
Great. Thank you, Jeremy. If you can keep your screen up for a little bit. Adam, do you have any questions for Jeremy?
Yeah, I guess I just had one question. When you were going through the select k-best and you were deciding between, and you still had like scaled and unscaled features in your data set, I'm just wondering like how you got to this point and why you decided to go forward with the scaled and the unscaled features.
I got to this point. I probably wasn't as refined as I should have been, but I ended up moving my scaled data back together with my unscaled data just so that it could be, I just thought it'd be easier for me in the future if I wanted to look at the unscaled for some reason, rather than having to hop between different variables that I have saved and maybe forgetting, oh, what did I save that under, just to kind of have it with me the whole way. And then it had suggested to use all 4. And I just decided, since I'm using more than one group anyway, I just thought, why not, just to see how it looks in the end. Maybe not the best decision or best method to decide, but that was just kind of what I was thinking at the time.
Okay, thank you.
Yeah, thank you, Jeremy. I have another question here. In your output here for the RMSE values for these various models, that top one there in the select group 1, you have a training in sample of 0.1738, and then you have a validation sample of something like 118 trillion. Did you have an explanation for why that validation out of sample number was so large?
I really don't. Whenever I was working on my working notebook, I had the same thing happen, and then I reran it after I reset my kernel, and it ended up fixing itself to looking something more like group 2. And then it happened again here on the final notebook, and I tried resetting the kernel, I tried rerunning it, and it just stayed the same. So I don't know if it's an issue with the Jupyter notebook or if there was something that I did when I was transferring the data over to the final notebook that maybe tweaked it a little bit, but it was kind of a late error and I didn't really have time to kind of ask y'all what y'all thought. So.
Gotcha. And then my last question is, you mentioned that you beat baseline by 11%. How did you come up with that number? How did you compare your final model to baseline to make that statement?
I divided the root mean squared error of the test by the baseline and then subtracted that from 1.
Um, yeah, the only reason why I ask is that your lasso large model was used on your test, is that right? And it was the only one that was used on your test?
Correct.
Okay. And so it'd be kind of difficult to say that. I mean, we can say that it beats baseline maybe at the validation step, but we don't really know how the baseline performed on test
Okay.
because we never actually ran it on test. So it's kind of like saying that you beat it by 11%, but you're sort of comparing two different data sets, two different performances. So I just wanted to double check to see how you.
Okay. So in the future, whenever.
Well, I'm more glad that you at least only used one model on test. That's I think the bigger thing that I was more concerned about. Yes.
So whenever that statement is made, I should just be comparing the validate performance with the validate baseline.
I mean, you could, yeah, I think that you could either say it that way so that you're at least comparing the performance on the same data set, or if you wanted to sort of roughly kind of give an idea of how these things perform, then you could say that, you know, on your test data, you had this RMSE with your model compare that to the validation, which is also another out of sample set. And that's how the baseline performed. Just being a little bit clear about where those comparisons are coming from, I think will help make sure that we're not confusing the audience.
Okay.
Yeah.
I appreciate it.
Awesome job, Jeremy. Great from start to finish. So good job.
Thank you.
All right. It looks like up next we have David. All right, David, just give us a moment I'm going to pull up your GitHub here. Cool. And Adam, you ready with the time? Awesome. All right, David, whenever you're ready to get started, go ahead.
Thanks, Adam. Hi, my name is David Sham, and today I'll be presenting on predicting log error for Zillow. The goal of this project was to identify Zillow's key drivers of log error, and I'm using our predetermined data set, which was single-family properties that had a transaction during 2017. Below, you can see my initial questions along with my clustering exploration questions. For the sake of time, I'm just going to go over my initial questions right here. I looked at whether bedrooms, bathrooms, garage spaces, or location by county affected log error, and I found that all of these were statistically significant, and so I moved forward with all of these to my clustering. And then I'll review the clustering questions when we get to that point. Below is all the modules I imported along my data dictionary. I acquired, calling my acquire PY. I did the same for my prepare PY file, doing the appropriate changes here that you see listed. And we see that all said and done, our data frame looks good to move forward to exploration. For context, the data set that I started with once I prepared was 48,250 homes. So once again, this initial exploration is pretty dry, and I found that all of these were statistically significant. So I'll just skim over this, found that there. Now moving on to my clustering, which is a little bit more interesting, I found that in order to have any chance of beating the Zillow algorithm for predicting log error, I was going to need to cluster some of my data. So in taking some of the variables that I looked at in my initial exploration, my first cluster, bedrooms, bathrooms, and garage spaces, does that affect log error? I found that indeed it does, although garage spaces was not significant. So I replaced that with age of a home and binned that. My second cluster, location, latitude, and longitude, also was found to be potentially significant. Yet my third cluster, square foot, lot, square feet, and the bath to bed ratio was not deemed to be potentially relevant. So in looking at this, it's very difficult to tell from some of these box plots, but through running some very basic statistical tests, I found that these did have potential significance. So I moved forward with these first two clusters and created these to move on to modeling. Here I scale the appropriate features to move forward into creating my clusters. This first cluster we can see choosing my best K value. And the interesting part is the visualization that I made for each of these clusters. From this, I can tell that this could be potentially effective for modeling. So I'll move forward with this one. And I just thought this was a cool graph, which appears to kind of plot out the geographical coastline of Southern California. So I thought I'd share that. It's kind of an interesting touch. Again, my third cluster was irrelevant. So here, moving on to predicting log error, I evaluated on root mean square error, scaling my data appropriately, splitting on X and Y, creating my baseline. And now I move on to fitting my best three models, namely linear regression, lasso Lars, and tree regressor. And when I fit and predicted on our train and validate, I found that we found essentially the same results across the board. So moving to my test set, I chose simple LM or linear regression and found at the end of the day, my model marginally beat baseline by approximately 0.14%. So what does this tell us? I think really we could do a better job of predicting log error if given more time and ability to really dig down and analyze this data set, perhaps produce better clusters. However, my recommendations for Zillow would be to collect more data on location-based features such as proximity to local schools, emergency services, and local parks and recreation areas. I think this could make our model more robust. If I had more time, I would further dive into census data to better identify some of those specific neighborhood attributes that could lend to a more accurate log error prediction. That's my time. Thank you so much. And I open the floor to any questions.
Thank you, David. So the first question that I have is that I noticed that you scaled your data as a pre-processing step to your modeling phase. Did you use scaled or unscaled data in the clusters themselves?
I used, in order to create the clusters, I did use scaled data. When I explored my clusters initially, that was not scaled.
Gotcha. Okay, great. I just wanted to double check that. So then that extra sort of scaling step that you did as kind of pre-processing to the modeling, when did that come into play? Why was that necessary?
So that was to split. I did this initial scaling on train, validate, and test, but I didn't split it, X and Y. I suppose I could have, but just for my own workflow, in terms of dropping a lot of those extraneous features, I thought it would be more efficient to split on X and Y after the fact of creating my clusters, so I could just real quickly drop any extraneous features that I wasn't going to use in modeling and split it that way.
Okay, cool. Adam, do you have any questions for David?
Yeah, I have a question. I was looking at your notebook as you were going through some of the evaluation of your models, and I noticed that a lot of your models were around 0.017, and then there was this actual row that said 0, and I was curious about that.
I apologize. I'm not sure I can pinpoint.
There, like right there.
Hmm. To be honest, I'm not sure what that represents.
Okay.
Or why that is there. I have to be honest with you. I would need more time to reassess my final report and get that answer to you.
Okay, sure. And then I just had one other small question. You were talking about some of your clusters and saying that some of your findings were potentially significant. And I want to know, did you determine their significance for sure using some statistical tests? Or were you just kind of dancing around that language because visually they looked different, but you hadn't tested for certain?
That's correct, the latter. So visually, it looked promising. I did not run specific statistical tests just due to time.
Okay, awesome. Thank you.
Thank you.
Yeah, great job, David, and excellent job on handling those panel questions. All right, up next we have Jessica Gardine. Garden?
Girding,
Okay,
like girding a castle.
gotcha. And just give us a moment to pull up your report and get everything set on our end.
So when you're pulling up my report, I did go through and labeled every single cell, whether it's going to be like a skip or a slide. So kind of I can hit play and it'll show you all the cells I labeled as slide.
Okay.
So I was going to present that if that's okay. Have this up and then.
Yeah, I'm comfortable with you doing that for this presentation. I don't want to
So-
change things on you too much at the last second, so.
Okay.
Okay,
So everything is taken directly from the notebook. They're all the cells are just labeled slide or skip. So everything in this is taken directly from the notebook.
gotcha. Just give me 1 second. It's taking a little bit to render your notebook on my end, but
I commented at all the pair plots, I promise.
okay. Yeah, there's something, we'll talk about it later. There's something interesting going on with your notebook and GitHub that we'll need to get clarified later. But for now, whenever you're ready, we can get started.
I did just run it like a second ago and it ran
Uh-huh.
just fine. Do you want me to just re-upload it real quick?
No, it's okay. We can always follow up on that afterwards.
Okay, like I put pictures in and everything, so you didn't have to load it from scratch.
I see.
Okay, then are you ready?
Yeah, we're ready.
Okay. Hi, my name is Jessica Gardine, and today we'll be talking about predicting log error. So the first step was to acquire from MySQL and clean the data. There were 36 columns that were missing over a third of their data, so I dropped those from the beginning. There were also several text columns, and since log error is computed using text values, I chose to drop all of those so I wouldn't have any target leakage either. Year built had some nulls, which I filled using mode. For size, lots of square feet, a lot of the different sizes had very skewed data sets. So instead of using the mean, I chose to use the median. There are also some that were like extremely large and identical. So I suspected those weren't actual values and I dropped those as well. Location, I did mode for zip and city because the mean of a zip code has no meaning. And I also dropped all the duplicate rows. This resulted in a final data set of log errors or target variable. Both size and location still had quite a few features. For time, I had year built and transaction date. And for other, I had property county land use code. So I first took out a location and I did go through and graph everything and look at different angles, but I'm just going to show you one graph for now due to time's sake. So you can see there's like these little kind of columns on the outside, but the bulk of the data is centered at 0 and has a horizontal trend. For time, I saw the same things, like columns on the outside, bulk of the data is centered at 0, horizontal trend. And size, once again, bulk of the data centered at 0, horizontal trend. There's a little bit more deviation from the center, and I found looking at it, this is just the bulk of the data is between 2 to 6 bedrooms. So it seems if there are outliers, it makes sense they kind of have more in that region, just there's more data points in that region. Land use code followed the exact same trend. So then I thought maybe I'm looking at this wrong. Maybe I should look to see if there's just any trends in log error itself. So like maybe it trends, there's too many positive or too many negative. And even looking at that, I found it was very similar. So my explore takeaway was keep exploring because none of these have a very strong correlation that would help me predict what I'm looking for. So I tried clustering to see if clustering models might find trends in the data. So first I split my data and then I scaled it. I did 2 different scales. I did a standard and robust because we had a lot of outliers and robust is usually better at handling outliers. So I wanted to throw that one in there as well. I chose to cluster locations and size for the same reason that there's a lot of features here and I wanted to minimize the amount of features I throw into my model to minimize noise and things like that. I also want to look at transaction data. The market gets hot and cold depending on the time of year, things like that. So I thought that would be a good one to cluster as well. For the location cluster, it's split nicely into 3 clusters, and I ran a t-test to verify that clusters are indeed statistically different. Again, I did this same for the robust and the standard scaled data sets independently. The size cluster unfortunately came up with a lot of different sizes and it would actually have me adding more columns and more features. And I was worried that it would actually create more noise than it would give information. So I kept square feet and lot square feet, but I ended up combining bed and bath as a bed times bath column and just using those as is, not doing the cluster method. Time sold split nicely into 3 clusters. And again, I used a t-test to verify the clusters are different. This ended up with about 4 continuous columns and I encoded my cluster columns. I also compared the cluster size. The smallest was 2.5 thousand and the train set's about 29. So I don't think the curse dimensionality will be a limiting factor in model accuracy. So I went ahead and continued on to the models. I started with my baseline. They have both positive and negative numbers in the target variable. So I took the absolute value first, then I calculated the mean and compared it to actual. I was evaluating the models based off the root mean square error and the number to beat was 0.1665. The models I chose were general linear model, polynomial regression, Lasso-Lars, and linear regression. I played around with the hyperparameters and these are the best ones I've presented here. As you can see, the models did a fairly good job representing the data towards the center, but it did not do a very good job at these tail ends here. The robust scale data had the same problem. Again, the robust scale went through all the same models and it represents the data towards the center, but doesn't do a very good job representing the data at the tail ends. By ranking it, it was very clear that the polynomial regression of 2nd degree was the best model. And the difference between standard or robust scaling was very minuscule, but technically standard did win. So I ran the standard scaling on my tests and I got a 2.29 increase in accuracy. So in conclusion, the polynomial regression of 2nd order gave the best results. For future work, I would like to continue analyzing the independent and dependent variables to see if I can find a stronger correlation. I would also like some more time to work hyperparameters, but mostly I would like to split the data set. There was a lot of places that had like 0 bed and bath, and I would like to split the data into land, home, and like large homes or mansions. I chose 5 because a lot of the realtor websites I visited generally split it based off 5 or 6 bedrooms. And since that's already how it's marketed, I thought that would be a good way to split it and give you a multi-model approach that might be more effective. So thank you. Again, all of these cells come straight from the notebook. So if you have any questions, let me know.
Great. So thank you so much, Jessica. I do have a question. So you talked a little bit about how you clustered on the transaction date. Can you talk to me a little bit through about how you kind of accomplished that or how you dealt with that date column?
That's the other thing. Scrolling gives me kind of a headache, so I try to do the slide thing. All right, clustering on transaction date. So that was a fun one. Sold, I think is what I called it. So that one I had to, first I converted it to a string. All of them were done in 2017. So that is not necessarily redundant, but it's not going to separate our data because it's the same for all of it. So I first converted it to a string and then I got rid of the 2017 and the spaces. And then I converted the dash to a decimal place. And I understand that like 9.12 isn't really the same as 9.5 because it's really about halfway through the month. But based off the time, I did leave it, at least it would be sequential in order. Although the decimal places are not accurate in magnitude, I do admit that. And then I converted them to floats. So now I had numerical data that I could cluster. I did this for the train, validate, and test. So that's how I clustered it. All the clusters were decided on based off what angle is most acute in the elbow test. For this one, it was 3. And it split nicely into 3 clusters, and they were statistically different. So I kept it.
Gotcha. Okay. So I see. So creative approach for sure. And to your, we haven't gone over handling time series and date type objects and stuff like that in Pandas. So I think it's impressive that you at least came up with a strategy for how to deal with the date column there. And I think that in the future, we'll have some better methods for you to use to deal with daytime.
Excellent. That was a pain.
No, I was just curious because we hadn't gone over it yet in class. So I was curious to see what you had done. Adam, do you have any questions?
Yeah, I have one question about how you were handling some of the null values in your data frame. You talked about how for some of the categories, you ended up imputing the median because you knew the data was skewed. But then for the year built, you ended up imputing the mode. And I was curious about your decision to do that.
So the year built category, they didn't include like decimal places in their years. And I knew if I calculated either mean, I would end up with decimal places. Mode's usually my go-to based off when I was researching just what people were recommending. Median I used because median became super relevant in where to go lot size. So and the lot size, hang on, I can draw this draw. So generally if it's something like this, I'll I can use the mean. It's a little nicer than that. But a lot of the lot sizes were very kind of skewed like this. And so if I use the mean, it was giving me like a data set way out here. And the lot sizes were all different because they go down to decimal places. So using mode wasn't really an option because pretty much every value was unique. So I chose the median because it gave me something close to this, which is the most likely choice. So I tried to just pick between median, mode, what I thought would give the most accurate representation.
Okay, awesome. Thank you.
Yes, good job. Excellent. All right, up next we have Chen.
Yes.
And whenever, if you can share your screen and then just give us a moment, I can pull up your GitHub. Okay, I'm ready to go. Adam, are you ready? Cool. Shan, whenever you're ready to start, go ahead.
Okay. Good morning, this is Chen. Today I will present my Zillow clustering project. My goal is by analyzing the 2017 Zillow single family data, find out the key drivers for the log error, then use the clustering and regression method build a model to predict the log error. Also, I will give out my recommendations and next step. Here are 4 initial questions I will explore and also the data dictionary. To acquire my data, I use a MySQL server, and this is how I acquire my data, clean up my data. That's a lot of information listed here, and also split my data. Those are all the libraries I will use in this report, and also the data context. There are about 52,000 observations in this data, and I selected 19 features to explore. Here is an overall view of the log error distribution and also the location information. Before we explore the data, we need to impute the non-values. This is what I did for the non-values. The question number 1, does the log error related to the location? The first chart is by county and the second chart is by city. The charts and the statistical tests prove that the county and city do have a correlation with the log error. The second question is Orange County's average house price different than the overall average? The chart and the statistical test also shows us Orange County's average house price is higher than the average. The third one, what about the relationship between overall house value with the log error? From the scatter plot and also the statistic tabs, it shows the house value has a correlation with the log error. The last one is about the relationship between property type, square feet, room count, house age with the log error. From the charts here, we can see the differences between different groups and also some kind of relationship being there. But all the statistical tests I did in my workbook failed to reject the non-hypothesis. To summarize the exploration, location and price are definitely related to the log error. The other features didn't meet our confidence level with the statistical test, but we can still see some difference within different groups in the chart. Before the clustering, I need to split and skew my data. The first cluster is by location. I use all the features related to the location. This is all the process here, and the chart looks pretty good. The second cluster is by house size and the age. Here is the result. The chart looks very messy here. Then the last cluster is all about the price. Here we can see the chart looks pretty good on this one too. Then I use the RFE to pick the top 5 features for my modeling. Because the house value is a continuous variable, so I will use 5 different regression models later on. The metric I will use is RMSE, since it's very common to use and very easy to understand. And here's my baseline and the evaluation score. The features and models I will use are listed here. As you notice here, the features, none of them are from the clusters. Here is how I create my model, fit them on the tree, and the evaluation score. Then I pick the top 3 models from my validated sets. It seems none of them are overfit, and the best model is the interaction-only polynomial. Move on to fit my best model on the test set. The evaluation score looks not good, even didn't beat the baseline, and it seems that this model performs worse on the smaller data set. Here is a chart for the best model performance. According to the test result, I expect there will be a 0.17 log error for my future prediction if the data source has no major change. In this project, we created 3 clusters to explore and build a interaction-only polynomial regression model with top 5 attributes to predict the log error. The RMSE for the test set is 0.17, and the best model failed to beat the baseline. Here are my recommendations. From the RFE result, none of the clusters seems too useful. Therefore, I would say that maybe clustering is not the best approach for zero data. And also, according to the poor performance for the model, maybe the linear regression models are not the best fit for some non-linear features in zero data. And we need to do some different models to predict the log error. And also, there's a lot of missing data for the pool and brush, so it would be better to have more data on those parts. And the next step I would like to do is I still want to explore more about the cluster to see if it's really not helping at all. And also, I would like to build different types of models to have a better prediction of our target variable. Thanks for your time, and please reach out to me if you have any questions.
Awesome job, Chen. Thank you. Adam, do you have any questions for Chen?
Yeah, I have one question. I may not have caught this while you're going through earlier, but did you end up involving any of the clusters that you created as features when you did your regression modeling?
No, I didn't, because I used the RFE to select the top 5 features. None of them are from my cluster, but I tried put the number 8, then one of them were there. So my conclusion, maybe the clustering is not the best approach for this data set.
Okay, and then I do have a follow-up question. I noticed that when you're running this recursive feature elimination, you're using the linear regression model to help you select these features. Do you think that could have played a role in the linear regression model becoming your best performer throughout this notebook?
I didn't go through that much from the feature collection here. And I think if I use a different model for my feature collection for the RFE, I will end up a different result. That it will be another wrong of the project here. And I wish I can have more time to play a little bit more about this. And also for the feature collection, I use the RFE and the KBAS. And things turns out KBAS doesn't have that good performance as an RFE. So I picked the RFE instead of select KBAS.
Okay, awesome. Thank you.
Thank you, Chen Chen. One last question that I have is, you have the feature of city that was used as one of the variables that was inputted into your model. How did you handle that city data in such a way that it ended up being just a single column?
At first I think maybe there is like maybe 1,000 or more cities there, but when I plot the chart here, I realized city is not that much. Even it looks like a lot here, but it's not like more than we can handle. So that's why I still scale the city, and it's still pretty good on the cluster and also for my mom.
I see. So in the data, and just maybe clarify this for me, is that city column, are those numeric values or are they string values? How are they handled in the original data?
They are the numeric values.
Oh, okay. Okay. So I think that my concern is that these city values are numeric by coincidence, when they're really more of a categorical variable. So I think that that might have also contributed a little bit to why your model may or may not have, but may have contributed to why your model was struggling to beat the baseline, possibly because of the use of city and almost kind of the randomness of how those numbers were applied to these, what were really like strings of cities. So I guess my question to you as a follow-up is that knowing that city is a categorical variable, how might you be able to transform or manipulate this data in some way to better serve that data type?
You mean if I get the data with the city is a categorical variable?
Mhm.
I think I need a list first. Then also group all the cities. I don't want every single city. I may group it like a different area. Like use the grouping to make the data a little bit like more focused on different group, but not by every single city.
Okay. All right. Thank you, Chen Chen. Appreciate your presentation. Well done. Up next is Mihail. And we can get a quick sound check. Mihail, I think you were muted when you were talking just a moment ago.
You guys hear me okay?
Yeah, we can hear you great. Give me just a moment to pull up your report and then
Okay.
you know when to get started. Cool. Okay. I'm ready to go. Adam, are you ready to go? Cool. Whenever you're ready, go ahead and get started.
All right, sounds great. Just start next time there. Hey, good morning, everyone. My name is Mihail Mariano, and today I'll be walking you through my Zillow clustering analysis. To begin, did it ever occur to you that when we think about styling our homes, we typically start with a broad temporal design topic like modern, traditional, mid-century modern, industrial, or farmhouse? What if I were to tell you that much like how we choose to decorate our homes, there's also a preference for the era when homes are built? Additionally, research shows that the age of first-time families has also been on the rise for decades. This trend, along with a decrease in average family households, might also be reasons why families are letting go of big houses with picket fences for smaller, more practical and sustainable spaces. Market preferences like these and changes like these to include fluctuations in seasonality that I introduced in my regression analysis are exactly the kinds of topics I set out to explore and reframe how we look at housing information to assess their home value. So in brief, I first acquired and cleaned the Zillow data set. I used an IQR method to determine outliers in the data set and filtered out homes for a $1.2 million valuation, as this proved to be well over the median single family household range in the state of California. I dropped initial records with over 80% null values, which also left me with approximately 40,000 unique records. I then identified and treated remaining missing values using a k-nearest neighbor imputer method. I created and tested hypotheses to explore the market trends I was curious about. I binned statistical hypotheses, I binned and grouped data set features to create unique classification clusters to use them in unsupervised machine learning models and better segment the real estate data. 3 distinct models that I generated were monthly clusters, error clusters, home size clusters. I then deployed the clusters and created both linear and nonlinear statistical models to predict logarithmic error. And finally, I evaluated the performance of my models and generated recommendations for follow-on analysis. So today I'll only be covering one primary hypothesis question and cluster used in my analysis. Yet if you'd like to learn more about the individual steps taken here, you can navigate over to my GitHub page, which I linked in the chat box. So let me quickly navigate you to build home error cluster. So this is my first initial question here, which is there a difference in log error across building error? So using a pandas QCut method, I've binned years by distribution of the data labeled clusters as 1907 to 1949, early 20th century, 1950 to 1959 as mid 20th century, 1960 to 1976, late 20th century, and 1977 to 2015 as new century. I created a hypothesis question and used an ANOVA test. This test returned a p-value less than the accepted levels, which to me signaled that I could continue further into exploration. So moving on into modeling. So in modeling, I used I used 2 primary methods for modeling. One was linear and the other was nonlinear. In nonlinear, I used principal component analysis, PCA, and polynomial regression with a degree of 2. I then went on to scale my data and incorporated additional tested independent features, which was living square feet to uniquely create the error cluster. I then went off to fit my clusters using sklearn's k-means method and plotted the cluster's inertia using an elbow method to determine the proper distance from the determined centroids plotted in the k-means algorithm. I should also note that in using the clusters and independent tested features, since modeling with additional features didn't add much significance to my predictive models, I solely went with clusters I created and generated models from within. I established a baseline mean error to evaluate my models against, which was approximately 5% margin of error. I then resplit my data into X variables and target variables. I then ran 5 distinct models, again, 3 linear and 2 nonlinear. All models returned similar results, none of which were able to predict log error better than the baseline. Yet ultimately, I deployed the polynomial model with a degree of 2 on my test set, since visually it appeared to be more evenly distributed across actual log error. And that's my distribution here. So in closing, my recommendations include conducting a build home style analysis to record the differences across error architectural styles, and test whether or not the unique architectural design styles of the home can directly impact its predicted value. Examples could include Cape Cod, French country, ranch, cottage, brownstone, etc. I would also incentivize and elicit through survey what unique design features home sellers or potential buyers have included in their homes and or are looking for in their next home. This can also help us to understand homes' unique internal design components that have been introduced over the years and test whether or not this helps to determine the home value story. Looking ahead, I would acquire a full Zillow data set for my analysis. I would attempt to view the segment the transitional periods in other meaningful ways, such as weekly, bi-monthly, quarters, bi-yearly snapshots. And lastly, I would convert longitude and latitude to proper plot coordinates and measure the relationship to log error and home value. So that concludes my analysis, and I will take any questions if you have any.
Thank you, Mihail. I appreciate the context that you said at the beginning. That was valuable. And I think it was interesting, kind of an interesting take on sort of segmenting homes based off of these kind of domain knowledge specific kind of styles, architectural styles or time periods. I thought that was really interesting. When you developed your clusters, and presumably from the looks of it, when I was looking through your notebook, you one hot encoded them. Is that correct? Is that kind of how you handled them?
So not initially, I did not know.
Okay.
Let's see. I don't believe I did. I
Okay.
did create dummy variables after having plotted the actual clusters themselves.
Okay, but yeah, so once they were moved into sort of the modeling phase, or as preparation for the modeling phase, you did create dummy variables for them.
Yeah.
How did you have a lot of clusters here, and it looks like you're, which is great. You investigated a lot of different clusters. How did you decide which were going to be used in the final model? Walk me through your feature selection process.
Yeah, absolutely. So I actually wanted to take a slightly different approach in that I didn't want to use other independent variables that I didn't use for clustering. I actually wanted to just see how the clusters themselves would measure up to predicting log error. So ultimately what I ended up doing was just including these in my xtrain and xvalidate, and then running a recursive feature elimination method to just determine which features within those clusters would ultimately grant me the best outcome at telling that logarithmic error story.
Okay, so did any of the clusters get used as a feature in your model?
Yes, so all but 3 clusters ended up being used in my model.
Okay, so your model was almost like a modeling entirely off the clusters. Is that correct?
That's correct.
Okay, interesting.
And I should also just know I also included independent variables not included in the clusters themselves and tested that as well, and ran a completely independent test to that. And they didn't prove to actually add any statistical value in predicting log error. So I decided to just present the clusters themselves.
I see. Okay, great. Thanks. Adam, you have any questions?
Yeah, I just have a quick question. I noticed that in calculating the RMSE for all of your models, it ends up just going to the 100th place. And sorry, this is a little nitpicky, I guess, but I feel like when the log error was so small, do you think it would have been more helpful for us to visualize your results going to the thousands or the 10,000th place?
Certainly, that's something that I definitely gave thought to after my MVP, especially while going through some of the evaluation methods that I used. I did notice that, I was trying to measure up against log error, which is already sort of a fraction of a percentage in some sense. But moving forward, I think I would to just kind of get that nuance of difference in the model's prediction scores versus the actual logarithmic error.
Okay, awesome. Thank you.
Yeah, absolutely.
Awesome, thanks. All right, up next we have Tim.
All right, can you hear me?
Yeah, just give us a moment and to load up your GitHub, and then we'll get started. All right, I'm ready on my end. Adam, are you good to go? All right, we're good to go. Whenever you'd like to start, go ahead and begin.
Okay, great. Morning, Kalpana. My name is Tim Kuriazis. Today I'm going to be going over my log error regression modeling using clustering methods. So last project, we dug into the Zillow data set, and I wanted to really get into, identifying some of the features that we can use that I could basically build from the set itself. So that was kind of one of my big goals. I wanted to be able to find features that I build to predict a log error, because I felt like the whole data set had a whole bunch of stuff going on. So goal of this project was create a model to accurately predict the log error determined by the driving features. So my initial thoughts were maybe there's a relationship between location and log error. And I also thought there'd be a correlation between what I was going to call luxury home items, such as pool, garage, number of rooms, and square footage. So my initial thoughts where I thought there would be a correlation to build those features out. So I wanted to, take the bedrooms, bathrooms, and the ratio of square footage and kind of engineer those things and incorporate it into them. So some of my key findings, after I removed some of the outliers, which I decided was going to be 6 bedrooms, 7 bathrooms, and a value of less than 3 million, and a square footage less than 10,000. So I found that the mean log error was this value here. And then I found my RMSE baseline was 0.175. And just as a heads up, my best model of my Tweety regressor, it matched the baseline performance. So jumping into the notebook, I have my imports here. Pulling from SQL, I use the function get connection, getting the single family homes. And I use this get Zillow function here. Wanted to take a quick look at the distribution of the target variable. That's the log error. We see that that looks good. I did notice that there was a ton of nulls. And for me, I spent a large time really handling the nulls. I wanted to make sure I got as much out of this data set as I could. So I built a large function to do this. The first thing I started with was this handle missing values function, which I took proportion. If there's anything was more than a certain percentage of nulls, I just dropped those out. And I got rid of those columns, just to do a quick clean sweep. And following that, I used my clean and prep function, which I built, which is my wrangle.py file, to ensure that the rest of the ones, so like make sure all the bedrooms that were 0 were taken care of, bathrooms were 0 taken care of, the item type or data type none for garage and pool were also handled. I made sure to change those to zeros, and it took me quite a while to get the data what I wanted to do. But as soon as I did that, I used this big function, clean and prep, and then I optimized my types to make sure that they were ready to do. And then some last minute feature engineering. I created luxury score, which I told you was like pool count, garage count, bedrooms, bathrooms, and air conditioning, which I encoded. And then I also wanted to take a look at that luxury score with its square footage divided by the age. I really wanted to see how many of these I can tangle up to get in one variable together, getting those aspects of the data together. So getting into the exploration, I knew where I wanted to look. I observed the outliers. Like I said, I told you, I got rid of 7 or less bedrooms, 6 or less bathrooms, 3 million less value. So I split the data, wanted to take a look at what the binage on the log error looks like, and I wanted to see if I can come up with any indications here. I thought that the larger longitude, which meant farther west, correlated to lower error. I also thought that it found that there was cost per square foot was lower. Maybe there's a correlation to higher error. So I also thought their lower square foot room ratio pointed to higher error. So I went through these pair plots and kind of developed what I wanted to ask my questions. So I put together 6 or 7 null hypotheses, and I tested them to find out which were going to be statistically significant and which were going to be the correlation. So I have the summary here for your guys' viewing. You can check that out. After I found out which one I wanted to move forward with, I scaled my data. Taking my scales, I then wanted to see if I can find some clusters. So I used that scaled data to start building my clusters. First one I want to look at was the luxury type, luxury square footage per age, longitude, home value. Comes out looking like this. I took a look at the longitude, latitude, and some luxury, and I called that not Los Angeles luxury. So I excluded Los Angeles County, and I only had these ones. I wanted to see if I can get some good groupings, which I ended up liking what I found there. So fast forward, and also I like the longitude lat plot. The coastline looks pretty cool. So now that I have some additional features,
you got the 5-minute mark. You got 1 minute left.
So now with the additional features at my disposal, I wanted to get into the modeling. So the first thing I had to do was drop what I wasn't going to be using in my model here, and then W encode my clustering. So from there, I just want to take a quick look at the F feature in RFE to see what they want to tell me to do. Identify my baseline, shows me here. And then I'm comparing, I'm using the median. And then I did 3 different models, did the linear regression, Lasselars, I'm sorry, 4 models, Tweedy regressor, polynomial. I got to the Tweedy regressor being the best performance, tested that on the test set. And in summary, I found that it had the RMS score of 0.175, which is right in line with the baseline. So what I would like to do for next steps, I want to, continue to trim down the features and keep looking at, how we can get better idea on how these variables are working together. So maybe I can do a better job at analyzing the clusters a little better and naming them better. And that's what I would like to do moving forward. That was a little long, sorry about that.
Yeah, thank you, Tim. Appreciate it. I know it's hard when you're under the wire in that last minute to get it wrapped up. Can you scroll back up a little bit? I'm interested in hearing a little bit more of your thought process around this luxury score. I know that you kind of talked about it a little bit, but can you go into a little more detail about how you constructed that and what some of the considerations you made as to what makes a home more luxurious or less luxurious in a way?
Sure. So what I thought, and what's a feature that's going to make your home more valuable? If you have a pool, that's going to make it more valuable. If you have a garage, it's going to make it more valuable. I wanted to include fireplace, any of these kind of extra things. I did air conditioning, what kind of, I wanted to see if I could include solar. What kind of aspects of the home make it more value, give it a, higher luxury score. So I wanted to take number of bedrooms, number of bathrooms, garage, pool, air conditioning. And that's kind of how I built this luxury score here. I wanted to see if I could combine those aspects. And I wondered if that was going to impact the log error. And then now I had a luxury score. Now I wondered for an additional feature, how could that luxury score be combined with its age? Maybe the luxury score and its age together as a variable impacts the log error. So that's what I was thinking, and that's how I did it. In my mind, homes had high, if you have a 2-bedroom condo with no garage and 1 bathroom, maybe it's more standard, the log error is there, but maybe you have a higher log error if you have these luxury, or maybe it's the other way around. So that's kind of what I wanted to explore and why I created some of these features going through that.
Yeah, no, I love the creativity around the feature engineering side of things. Now, I guess my question is, it seems like your data set has a higher risk, a greater range of values in like bathrooms and bedrooms than some of these like 0 to 1 values in some of the other components of your luxury score. Would you ever consider maybe using scaled information?
So I took, when I was looking at that, I wanted to take and that's kind of where I did. And I threw in the luxury score times the square footage divided by the age to kind of even out the numbers. So if you have, 1 bedroom plus 2 bathrooms plus 1 pool plus 1 garage, that's going to be your luxury score. But then if you kind of scale it with my own internal scaling by multiplying it by its square footage and dividing by its age, it kind of helps even out the data across the board with the different numbers that are coming in. So if you have, because the luxury score, I wanted to keep it simple. So if you have, 10 bedrooms and 10 bathrooms, your luxury score is going to be 20. But if you have, 3 bedrooms, 3 bathrooms, a garage, a pool, and air conditioning, maybe your luxury score is like 11 or whatever the number is going to be. So I kind of had that just as a baseline for it. And then the luxury score times the square footage divided by the age to kind of help normalize it a little bit.
I see. Yeah, I think that I like the core idea of what you're doing. I think I like one of the risks that we run into with sort of feature engineering is sort of the big pot of stew method, where we're just sort of throwing things together and kind of multiplying them and dividing them and just kind of seeing what comes out of it. And while sometimes we get lucky, because something comes out that ends up having some relationship with the target variable, that also can be kind of a risky situation where we can get lost in this black hole of finding every possible combination of features.
Sure.
just sort of seeing what happens. And so that's why I was interested in sort of this idea of, well, let's put some reins on that process and try to define within the constraints of the data that we have, what this idea of luxury is. And so thank you for kind of walking me through it. As your thought
Kind of
process.
funny, you know, when I performed the F feature in the RFE, they liked my luxury score. So I was like, this is good. I mean, the cost per square foot is another one that I did, and then luxury score. I was like, well, so what I'm trying to eliminate all of the different features, and I want to create one feature that takes in aspects and elements of those features to one. And I wanted to see what the machine learning would do, because, you know, I think there could be a pattern, but I'm gonna see what the machine thinks. We'll see what the machine can find.
Yeah, awesome. Adam, do you have any questions for Tim?
I don't have any questions because you had so many good ones already. I just wanted to say, in terms of the timing of your presentation, I felt like just the acquisition and prep went like ate into too much of your time.
Yeah,
Because I would love to hear about these custom features you've made. I'd love to hear about your exploration and your modeling.
I had
And
to skip that a little bit.
yeah. And so like if I'm interested in how you acquired and prepped the data, that's something that I feel like you could expect me to dig into
Sure,
like on my own time.
sure,
But the work was great, so thank you.
cool. Thanks.
Okay, great job. Let's see. 1, 2, 3, 4, 5, 6, 7. Okay, up next we have Lindy.
Share my screen. Okay, can everyone see that? Okay.
Yes, just give us a moment. I need to pull up your GitHub here. Okay, I'm ready whenever you are. I think Adam, you're good to go. All right, go ahead and start whenever you're ready.
Okay. So this is my Zillow log error report. This project will be used clustering to find drivers of error in this estimate of the single user unit properties that were listed in 2017. The goal of the models is to improve this estimate of residual error. So these are my imports, and I acquired the data from SQL. And then when I handled my outliers and converted my data types and everything, I did that with essentially like 7 was my limit. So I stopped at 7 bedrooms, 7 bathrooms. I made these columns of acres that consist of square foot divided by the amount of square feet in an acre. So it makes the acres column. And then the same thing for tax rate, which takes in tax amount and tax value dollar count. So I dropped the columns that I didn't need. And then still, even after all of that, there was still a bunch of nulls. So because of time, I just filled them all in. And then I split it up into my train, test, and validate. So the log error distribution is normal. So I wanted to go ahead and take a look at that. And then this graph is, does home age impact log error? And we can see that there is some form of relationship here. And the same thing here with home value. And they might not necessarily be linear, but there is a relationship. So we're going to take those things and test them. So for testing, we did a Pearson's R test on home value and home age with the alpha of 0.05. We were able to reject the null for age with the p-value of 0.01. So they do have a relationship, but we failed to reject the null for the home value. And though they do not have a linear relationship, they do seem to have a relationship. So we're still going to continue with that. So for clustering, I had different groups. I did a lot of physical features in the first one: latitude, longitude, acres, square feet. And then the next one, I did more features: acres, or age, acres bin, tax per square foot, and then tax, which is home value, land tax, and tax rate. So I used min-max scalar, and then I used the elbow method to select what would be best for K. And so I think I went with 3 here, and then I put all of them, and you can see with the clusters, this was probably my best one. You can see the groupings definitely here. So I guess as tax goes up, so does log error goes down. My second cluster wasn't as good, and you could hardly make it out. It was really muddled. You couldn't really see any vague any groups. My third one was slightly muddled as well, but you could still see like a general clustering. So I guess as the age went up, log error went down a bit. So with modeling, we used select K-best to pick the top three features, which was finished square feet, dollar per square feet in Orange County. And I split my data into X and Y variables. I did random forest, decision tree, and linear regression. And we went ahead and dropped cluster 2 since it didn't really add anything, and I didn't want it to mess up my model in any way. So yeah, we did select K-best, and we got our best features. And so when we put it in, we also made a predictions table to put our predictions from our models in. And at the bottom here, you can see that all of them, not in train, they didn't really beat the baseline, but they all performed better in validate. So my best performing model is my decision tree that outperformed in validate, but it actually was the lowest in the train. But that's the one I did test on. So conclusion, we can see that we didn't use any of the clusters we actually made. So those weren't very useful. Tax and home value have a higher than average log error. Main features used seem to be focused on location, costs, and size. The next steps I would suggest is getting more information about the area, maybe ISD or things that are surrounding it, and possibly getting homeowner information, maybe something about income, since a lot of the variables used for clustering were about amounts and things like prices and stuff like that. So just getting more information, maybe using a robust scaler next time. So yeah, if there's any questions, let me know.
Awesome. Thank you, Lindy. Yeah, so I have a few questions. So if you could scroll all the way back to the top, and we're looking at that first chart, maybe the second chart down right there. You kind of mentioned that there is a relationship. It might not be linear, but it's there. Can you describe, at least visually, what you see that relationship to be?
Well, I mean, they tend to focus right here. There's still a lot of outliers in this data, but the general focus you can see is all right here, and it follows some scale, some sort of thing in common that's keeping them all around that center line. So there's a relationship, but it's not the linear one that I'm used to seeing.
Okay. So I think that my recommendation here is to be a little cautious about some of these terms. So when we talk about like that there is or is not a linear relationship, to me, maybe as a viewer, I see a linear relationship as a straight line going across the stream. Or maybe the lack of a relationship at all. If the variance of log error is not explained by home age, then that might be why log error seems to go up and down randomly around as home age changes. Is log error significantly changing either, or does it seem to stay kind of zero the whole time? Then that to me suggests immediately, well, maybe there isn't a relationship between the two. But you might be able to kind of point your audience to perhaps these regions where if the relationship is not necessarily positive or negative, but that the variance shifts, you could have these regions where there's increased variance in the log error. You might point that out to them. Like you can kind of see this sort of ballooning in the middle. Or there's some of the charts that you had where the log error even though they always seem to be centered around 0, there was clearly these regions where the log errors tended to be more positive and more negative at the same time. That kind of that variance in the log error was not consistent, and maybe that's the relationship or pseudo relationship that you're trying to kind of point out there.
Yeah, that's a better way to describe it. So I'll take that in the future.
Sure. Adam, do you have any questions for Lindy?
Yeah, I have one question. I noticed that you were building some clusters with many features, and then you had sort of graphed maybe one of those features against log error in order to look for sort of nice groupings of your clusters, nice distinct groups. And I'm wondering if, you know, if there was a possibility to explore, you know, the plotting of other features and if that could affect how well these are grouped.
Oh, yeah, definitely. There's a lot more things I could have done. I could have done like tax rate or home value, and we could have seen those relationships. But I don't know. I guess I thought it was easier to read, so I just kind of put it in. It was easier to describe, so that's why I went with that one.
Okay, so maybe there would be a chance to see more distinct or more muddled based on what features you're applying on the axes.
Mhm.
Okay.
Yes. Yeah. Oh, yes. 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 Yeah. You'll be able to see kind of how the clusters look depending on where I put where, but this looked better, so I went with that one.
Okay, thank you.
Cool. Well, excellent job, Lindy. Thank you for the hard work you put in getting that together. Let's take a short break. We're about halfway through, so let's come back at 11 and we'll continue with the remaining presentations after that. All right, let's come back together here. Up next, we have Kevin.
Yes.
All right, Kevin, I'm pulling up your GitHub now.
Okay.
I'm chuckling at your title here.
Oh
remind-
yeah.
uh,
I like stupid jokes, and I figured it helps, helps stick in some people's memory if you can make a stupid joke. So doesn't make any sense at all, but
It's okay, it's catchy. All right, I'm ready to go, Kevin, if you're ready to go, and it looks like Adam's ready. So whenever you want to start, go ahead.
alrighty. All right, good morning, everybody. My name is Kevin Smith. I'm going to be walking you through the Zillow data set, which I'm sure you're all too familiar with by now. But as a quick reminder, what we're trying to do is we are trying to predict the log error and then leverage that to be able to better predict the home value. So we're trying to increase the accuracy of the Zestimate tool. So I'm not going to go into too much detail about the wrangle or the data acquisition or prep phase. If you wanted to ask about those or wanted to dig in for yourself, they're all those functions are available on my GitHub. But I split and scaled the data. I scaled the continuous, and I left the categorical or discrete and the target variable alone. So let's just dig into the exploration. I kind of put exploration and clustering all into one. I had a couple of questions that I wanted to ask, and like, how does latitude relate to your land cost per square foot? How does longitude relate to land cost per square foot? And can I cluster around those things? And the short answer is longitude does not have a linear relationship with scaled land cost. But as you can see, there are spikes here that made me think that maybe clustering might be a good option. Versus latitude actually has a more normal distribution, but since it's kind of skewed over here, that suggests that there is some form of correlation there. And then this doesn't really have any effect on anything, but if you put the latitude and longitude into a plot, you can see you have the California coastline. And when I was stationed there, I lived right about there. So I went through that and I created two more clusters, all based on three variables that I thought might be able to influence our model as far as being able to predict log error. So I'm not going to go into too many details about those, but I will real quick tell you what is in those clusters. We have the first one that I told you about that's got latitude, longitude, and excuse me, latitude, longitude, and cost per square foot of the land. Then you also have what I'm calling the area home cost. It's square feet, scaled acres, and scaled home cost. And then your location is latitude, longitude, and city ID, right? And I used the k-means method to determine how many values, how many clusters I should have. And as I'm evaluating these, I'm not seeing too much of an impact on log error for the first two, for the location or age bed cost. But for area home cost, I did notice that this fifth category here is skewing negative, which I thought that might be useful when we're talking about being able to predict whether or not something is negative in the log error department. So I converted that into a dummy to see if maybe that might be useful in my modeling. And then I split X to train, all that stuff, right? And then I went through the K-best feature selector to determine whether or not my feature was going to be useful. And it turns out, no, it's not. So I went ahead and moved forward with the modeling phase because I thought maybe I can beat the baseline anyway. And as it turns out, I can. My best two models were the polynomial and the linear model, but they actually performed identical to one another. So my conclusion is that when we're talking about linear regression, if we're measuring something like log error that centers around 0, that linear regression model is always going to skew towards 0. And unless you have some kind of a skew within the log error itself, it's not going to yield very good results. So I thought that in conclusion, I would like more time to explore the different clusters, different relationships that I might be able to cluster around. Maybe that might generate some more useful results. And also, I would like to try to see if it's possible to predict whether or not something is going to be positive or negative on the log error first, and then try to predict how much. Because if we're just going all in the same bag, it's all going to skew towards 0. So with that, I would like to open up my time to any questions.
Yeah, thank you. Adam, do you have any questions for Kevin here?
Yeah, my first question is, when you were going through the Explore section in your notebook, I feel like you had a lot of good takeaways and a lot of good visualizations, but I would like to know some of the main questions that you're trying to answer with this exploration.
Right. So my first thought was I thought that city might be useful, but I knew that since there were so many categories of city and they're not really numeric, the best way, in my opinion, for me to be able to get some kind of use or derive some kind of meaning from it would be to cluster around it. So that way it's not so many categories that I can't visualize something, but also, you know, when I'm putting it into the model, it doesn't mistake it for a numeric. So that's the explanation behind the cluster. The area home cost. Let's see, where was that? Excuse me. My thought process on that is the location geographically a lot of times is going to impact the cost of the home. And so I thought that maybe it would be a good idea to cluster around those 3 categories to be able to break it down and try to make predictions based on whether or not, you know, where it's located. And that one actually seemed to be, at least visually, the one that had the most impact. And then age bed cost, I had this idea that it's kind of a hunch that maybe the age of the home has a relationship to the ratio between the bed and the bathroom, which may have been more valuable at a certain time, but not as valuable now. And as it turns out, that was not the case. So.
Okay, thank you very much.
Yeah, no problem.
Great job, Kevin. I don't have any additional questions at this time. I appreciate the work you've put into this. Up next, we have Gladdy. And just give me a moment here, Gladdy.
Okay.
All right, I'm ready on my end. Devin, you ready to go? Cool. Whenever you're ready, Gladdy, go ahead and get started.
All right. Hello, everyone. My name is Gladys Barrios, and I will be presenting Understanding and Improving this estimate. Our goals for today are to use clustering algorithms to determine driving errors in the current estimate, trying to find and use different drivers of log error to improve our estimate model. And in order to do this, we will go through the data science pipeline. Here are some important libraries. First, what I did was acquire the data from the Product SQL database. I only acquired data from 2017 properties, and for single family homes, I went ahead and filtered it by single family residential. How I ranked out the data, since there's so many rows in the data set, I went ahead and kept columns that have 60% of the data, kept rows that have 75% of the data. And for some columns, I did decide to fill the rows with the mean of, the mean of the column. And I did this for columns that I thought were important, such as lot size, square feet, tax value, dollar count, and year built. For some columns, I did add new columns such as county, which displayed the name of the 3 different counties, age, which was calculated by 2017 minus the year the property was built. Acres was calculated by lot size square feet divided by the acre size in feet, and then I added some dummy variables for counties. For outliers, I went ahead and removed any properties that had 7 or more bedrooms or bathrooms, removed any properties that had 0 beds and 0 bathrooms, and then I also removed any properties that had acres greater than 20. So I went ahead and split my data and then scaled it as well. For my exploration, I'm only going to go over 2 questions here. The first one is log error significantly different for properties in the 3 different counties? Taking a look at my visualization and then my statistical test, yeah, log error is varied by the county. And then for my next question, is log error significantly different for properties that have different property values? Looking at my visualization and my statistical test, there is no correlation between price and log error, price of the property. And then for clustering, I used K-means clustering method. I did 3 different clusters. My first cluster is called size cluster. It includes bathroom count, bedroom count, and lot size square feet. After looking at the visualization here and running my statistical test, there is no linear correlation between my size cluster and log error. For my second cluster, I used location cluster, which includes latitude and longitude. After looking at my visualization here and then running a statistical test as well, there's no linear relationship between my location cluster and log error. For my third cluster, I did age size, which is just the age and lot size. After looking at my visualization and running the statistical test, there's no linear correlation between my age size cluster and my log error. So overall, there's no linear correlation between any of my clusters and log error, unfortunately. So when I was doing my modeling, I decided to do some feature engineering. I went ahead and did select K-best and chose the best 4 features. I did 4 different models. I did ordinary least squares, SLRs, and generalized linear model. I went ahead and calculated the best line, and our goal for today is just to find a model that has any RMSE score that's lower than our baseline RMSE score. So I went ahead and here are my models. I'm not going to go through all of them specifically. I'm just going to go through the one that was the best model, which is my polynomial model 2nd degree. And just scrolling down here, you can see the comparison. I did test the polynomial model 2nd degree with my test data set. As you can see here, the difference is not so different. This is my baseline, and then this is from my training, validation, and test. They're not so different. They are lower, but they're not so different. So in conclusion, from my whole report, we can see that some features do have a relationship with log error, but those relationships are very weak in order to create a great reasonable model. My recommendations are to try to find other key drivers of log error that I was not able to touch on. Keep improving the baseline model since it's a very good model to begin with. And there is a lot of missing data on several different columns. Maybe we could try to figure out a way to have somebody or us, I don't know, revisit properties or try to find more meaningful ways to acquire that, fill that data. And then for my next steps, I could try to make different clusters with different features, try to get different approaches from my peers or having different advice, and then trying different models such as classification models. But overall, that is the end of my presentation. Thank you guys for listening. Oh, sorry, I didn't mean to do that.
Yeah, no, you're good, Gladys. Thank you. Adam, do you have any questions for Gladys?
Yeah, so I guess my first question here is, you removed some of the homes with the greatest room counts, which is something that I've seen in many presentations today, but you also removed all the observations that had 0 bedrooms and or 0 bathrooms. And I'm wondering if you could walk me through your decision-making process on that.
Yeah, I felt like that was also a big outlier, was just having properties that didn't have 0 bedrooms and 0 bathrooms, since it's not very common. And I kind of just thought of that as like my personal decision. I just think that, you know, any property that doesn't have any bedrooms or bathrooms isn't really like very important in my opinion. But that's kind of how I walked through that.
Okay, and then I also have one question about your exploration. when you were reviewing some of your statistical tests, you were saying that there was no linear correlation between some of your features. And I was wondering if there was like absolutely no correlation or if there was no significant correlation.
No significant correlation.
Okay, so there might be a little bit of a relationship there.
Yeah, but it's not anything significant that I saw after running my tests.
Okay, thank you very much.
Well, I have a couple of questions, Gladys, if you don't mind.
Yeah, sure.
So near the end there, you talked about as one of the recommendations was improving the baseline model because it was a good model. How would we improve a baseline model?
I would say, I think the way we would improve that baseline model, I feel like since it's being used on this data set and there's so many like missing data, I think my idea of that recommendation was just kind of like trying to figure out ways that, I don't know, try to like fill the missing data that way they could work on that same model and see if that helps
I see.
improve it.
So in this case,
that
the
makes sense.
baseline, yeah, the baseline that you're referring to is not necessarily like what we've kind of termed baseline in the curriculum, but rather the existing Zillow
Yes,
model
yeah,
that is creating these
that's what I
layers.
meant.
Okay, yeah, I think that makes more sense. And then the second question that I have, it has to do with when you're looking at your clusters and you were trying to identify whether or not clusters had some kind of statistically significant relationship with the target variable, you used Pearson's R in order to make that claim. Can you talk to me a little bit about why you decided that Pearson's R was the appropriate test to use in this case?
I used Pearson's R. Sorry, I might blank out. I'm not used to the questions, but I believe it's because I did it because it's like two continuous variables, I think. I'm sorry, I don't really know how
Yeah.
to answer that question. I
No,
think I'm
that's-
going in the right direction, but I'm blanking out right now.
Yeah, no, I'm kind of putting you on the spot here, so don't feel bad. One of the things that I have concerns is that when we've created these clusters and they're given these labels 0, 1, 2, 3, that doesn't necessarily imply some numeric or continuous quality to them. They're still categories.
Oh, I see.
And so the fact that cluster 0 happened to be the first cluster that was listed and therefore given the number 0, and cluster 3 happened to be the fourth cluster that was listed and given the number 3 is kind of random. And so we have to be cautious about seeing a numeric value and running to the conclusion that it has a numeric quality. In this case, these clusters, those are names. And running a Pearson's R on a categorical versus continuous variable may have been the reason why you found no relationship. It's possible that had you run more of like an ANOVA or some other type of test of categorical to continuous, you might have had a better result, or more, at least you'd at least increase your chances of finding some statistically significant result. Whereas here it was inappropriately used in terms of the test that was selected. So
Okay, that makes sense.
yeah, I'm just glad that as long as it makes sense to you at this point, then that makes me happy.
Yeah, I think I just got confused because I based the statistical test off of the features and what they were instead of like what the cluster actually was.
Gotcha.
Yeah.
All right. Thank you so much, Gladys. All right. Up next, we have Meredith.
Can you see my screen?
Yes, I can. And if you give me just a moment, I'll pull up your. And it is the final report.ipynb, correct?
Yeah.
All right, great. Cool. All right, I'm ready on my end. I think Adam's ready on his. So go ahead and get started whenever you'd like.
Hi everyone, my name is Meredith. Today we're going to talk about how accurate is your estimates. So estimates are Zillow estimates on housing value, and log error is their evaluation metric, which tells us how accurate is this value. like their prediction. And our goal is to analyze what is driving this log error and to build a machine learning regression model that predict this log error. So if we look at our data and you see those empty spaces, those are the missing values. And beyond the missing values, we also have like other issues that needs to be addressed in order to get any sort of insight from the data that includes these outliers. And our data, of course, is split into train, validate, and test. So we have roughly about 45,000 housing data across 3 counties in LA. And we have a very normally distributed log error, which means that their estimates are already very accurate, and it's going to be extremely hard to beat the baseline. So we're going to approach this problem from 6 angles. First, let's look at how does location play a part in predicting log error. If you look at it on a county level, Orange County does have higher mean than the other 2, and it's also backed by a ANOVA test. What about latitude and longitude? They have weak to no correlation with the log error. And as for the zip code, I bend them into 4 groups based on how far they are from the overall mean by conducting t-tests on each individual zip code. So this is a location cluster that's going to be included in the final model stage. So what about area clusters? These are the area features, and I found they are very correlated with each other by doing a Pearson R test. And that's why I put them into a cluster to avoid multicollinearity. And judging from this graph, I can see my clusters do have a difference across, these 3 clusters. But ANOVA test actually rejected my hypothesis, but I'm still going to include this cluster just to test them out in the final stage. So the same case goes again with the size clusters. In the graph, you can see the more rooms you have, the higher the log error is going to be. And according to this cluster, I see my cluster is doing a good job, but ANOVA test actually tells us a different story. And the same case goes again with the value clusters. From the graph, I see there's a relationship when land value increases, this log error is decreasing. But ANOVA test again reject my hypothesis. I also explore the age of the house and the transaction amount of the house, and I'm going to include all these 2 features in my final model. So what we explore together, the location clusters are the most relevant and the most meaningful clusters. All the other clusters, even though they are visually meaningful, but they're backed by none of those statistical tests. So going to the modeling stage, if we have 0 feature in the model, the baseline is going to have an RMSE of 0.16. And this is the evaluation metric that is going to use on all the models. So I tried 3 feature combinations and 2 algorithms for each. That is going to give us 6 models. And the top 3 models are here. When I evaluate them on the validated set, you can see they have a lower RMSE, which means they perform better on the validated test. So that means our models are good and they're not overfitting. So the top 1 model is going to be this second combination of polynomial degree of 2 that performs 0.6% better than the baseline. And this is visually telling you how this is going to predict on the future unseen data. So in conclusion, location is the strongest cluster that we found. And all the other clusters are weak. And even though they're weak, but we still explore them in the final modeling stage. And the final model is going to perform within a variance of 0.17 on future unseen data. So what I recommend doing is that we can impute or handle those outliers and null values differently so that our model can also perform just as good when we have all these future data that we don't know if they're going to have those outliers or not. So what we can do next is that we can explore more feature combinations and come up with more different algorithms and can see which model actually perform better, and to try a different approach instead of just looking at location, size, value, and area. So that is the end of my presentation, and please let me know if you have any questions.
Awesome, great job. Great job, Meredith. Give me just a moment. I accidentally closed out my GitHub here that had your project. While I'm loading it back up so I can answer the questions I was thinking of answering, Adam, do you have any questions for Meredith?
Yeah, I have a couple questions about some of the figures I've seen. The first one is partially on the page here where you are plotting the results of your polynomial third degree regressor. And yeah, one more down, I think. Sorry. One more figure down in your thing. But I just found that I didn't really see any labels on the chart beneath this one where it has like a blue diagonal line and then there's like a red horizontal line. And I'm just curious, like, yeah, I'm curious what's being plotted on the axes and also what these lines are representing.
Okay, yeah. So the axis on the x-axis is the true log error, and the y-axis is also the true log error. So this blue line is the actual log error that's being plotted on this graph. So that is why that's a straight line. And in the middle, the straight line is the baseline prediction, which you see is because the baseline is the mean of the entire data set, and it's going to be the same. So that's why it's also a straight line. And all these red dots are the prediction from my final model. And you can see those range here are the variance of this model. I hope that answered the question.
Okay, yeah, that was very helpful for me. And then I also had a question about one of your first figures were sort of that geograph, so you can actually see sort of the topography of, you know, California. And then, yes, this one. And so then I just had a hard time interpreting the log error distribution graph. What scale is everything on? It's just a little hard for me to see.
You mean the log error?
Yeah, so in that like subplot within your big plot, I'm just curious like what the units are.
The x-axis are the true unit of the log error, which is 0 point something. And y-axis is just the count of giving you an idea of how distributed these log error are. So if you see like here, you have a high count, that means most of the log error is centered at this mean, which means the estimate are very good because the log error is approximately all centered at this mean area.
Okay, thank you. Yeah, I was just having a hard time interpreting it because I couldn't really tell what the scale was for log error along the x-axis.
Yeah.
But thank you for answering my questions.
Okay, quick question that I have, Meredith, if we can go back up to that really cool 3D plot that you made on bedrooms, bathrooms, and log error. Yeah, that one right there. I thought I remember hearing you say something along the lines of as the number of bedrooms and number of bathrooms increase, that log error increases. And maybe I'm just having a little bit of trouble kind of manipulating this. I'm sort of playing with this myself, but it seems almost like the highest absolute log error, both in the positive and negative direction, seem to happen kind of in the 3 to 2 range for both bedrooms and bathrooms.
Yeah, I think that was my error when I was presenting that.
Oh, okay.
Yeah, the less.
Cool. Okay, no problem. I just wasn't sure if I was missing something here. And then also, if you could scroll up just really quickly, I have some questions about that missing value analysis. Can you talk to me about this tool, essentially, that you kind of deployed here?
Yeah, so this shows you how much value this column actually have. So the more dense, like the bar is like all black, means that all the values are there. And all these empty spaces, those means that the values are missing. So when you see this, you can just tell which columns have more data than those does not have, you know, like not missing value.
Gotcha.
So yeah, I dropped the columns and rows that have more than 25% missing data, and the rest are saved.
Cool. Awesome. All right. Thank you, Meredith. Those are the only questions I had.
Thank you.
All right. Up next, we have Jared.
All right. Can everybody see that? And should I zoom in any?
I think I'm okay with it. I don't know if you might want to zoom in just a little bit more. Yeah. I think on the smaller laptop screens, it's a little hard to read.
Yeah.
And just give me a moment to pull up your report. Okay. I'm ready, and I think Adam's ready. Whenever you're ready to go, just go and get started.
All right. Hi, y'all. My name is Jared Angel. I'll be presenting today on trying to find the key errors, the key drivers of log error and improving our baseline model. I approached this a little differently. I wanted to make a robust model and something that could handle a lot of big variance swings. And my data acquisition is a little different. I filtered out by unit count of 1 and single family. And during my initial exploration, I found that the 2017 data only contained three quarters of data. So I went ahead and brought in 2016's, the last quarter of 2016, which is the first quarter of 2017 fiscal data. So essentially I'm looking at the entire year of fiscal 17 data. And another interesting thing I did was I converted all of my latitude and longitude into polar coordinates, which flattened out the three-dimensional latitude longitude to give a more accurate representation of distance. But as we can see here, since I brought in all the extra data, I have a lot more values, almost 80,000 in the entire, and after split, I still have 50,000 in my train. And that was actually after removing the outliers. As you can see, I used a K value of 3, and that only removed 700 or so observations from my data set. So that way I could use a robust scaler to kind of handle the outliers that it would still have trouble with the harder, more extreme outliers. But some of my first questions was dealing with location and why I made the polar coordinates. And what I did was I put them into bins here and then plotted them against the log error. And as a bin, you can see that it does vary significantly between there. So I went ahead and I kept those as well. And then I also broke it down into quarters, my date and time. And as you can see, we have a small variance, not too much to be seen here, but there is a little bit. With the third question, I wanted to look at how does the log error vary by month sold and by the census location. And my census location was all raw census. Another thing I did with the data was I didn't want to impute or fill in any null values. I wanted to keep the set as true as possible. And then with the census and blocks sold, my thought process was, okay, well, maybe some regions sell better at a certain time of the year. And as you can see, our model does predict better certain models a year and for parts of the data set or the location of the data set. And to kind of continue going with that, I wanted to look into the county instead of just the census data and see how that was affected. As you can see, it's similar, but it's not similar at the same time. But there is quite a big variance in that. Following up with the next one, I made a ratio of multiplying the square foot by the bed bath ratio. And my thought process was to kind of get rid of the multicollinearity between the two. And it would also kind of be in a roundabout way of doing a room size. And then I plotted that against the log error as well. And we could see we still have some variance with that. Unfortunately, none of my clusters tended to work out. And during my explore, whenever I tried to put that into the select RFE, they weren't selected. So I ended up not using any of those in my model. And my best model was a Tweedy regressor. And then as you can see, we came down here and I did my select RFE because there was no way I was going to be able to delineate between these bin names that I did not have time to rename. I ended up just throwing that all into the model and we got a slightly better than baseline on the test and validate. On the train, and the validate did a little bit worse. However, when I calculated it against the test, the model beat the baseline by 0.05%, which I think is pretty good considering we kept so much of the original data. But one of the big things I did notice that in my exploration was there was a large chunk of data missing that seemed to drive log error. As I dove into some of these problems deeper, I noticed that the log area did not vary at all with some of the features I selected. So that led me to believe that we are missing some key data in log error. So moving forward, I'd try to gain additional features that affect log error, try to get better for information and lower the amount of nulls so I could use that and compare the models to other states to see how the log error is effective. But overall, as a proof of concept, and I think working with the clusters more or exploring the bins further could offer a better performance. And that's all, if there's any questions.
Awesome. Yes. Thank you, Jared. Excellent presentation from start to finish. I do have a question. So during your data preparation stage, you remove the outliers and you only remove those outliers from your training data set. Can you talk to that decision and what that implies for out of sample evaluation metrics?
Is my understanding that it makes the model more robust. That way, when you have the outliers in there, it's forced to work with what it already knows from that training set. And then if some outlier comes in, a home comes in that could be in the outlier in the future, the model would still be able to work and predict with that.
Yeah, I kind of like to almost think of it as it's kind of like playing on hard mode. When you remove the outliers from only the training set, that means that you're trying to fine tune your model to better fit a specific kind of more focused subset of the sample that you have available. And if you don't remove those same outliers from your out of sample data sets, it's sort of like playing hardball in the sense that now your out of sample data set is going to include these observations that are going to be like extra challenging in a sense, because you're not removing them ahead of time to prevent them from being evaluated against. I know that I've seen some prominent data scientists suggest that that's, sort of an ideal situation. We want to challenge ourselves and our models as much as possible, but I wanted to just be sure that that was kind of running through your mind as you were making that decision, and it sounds like it was.
Yeah, I just kind of wanted to, I guess, challenge myself a little bit and do something a little different than I did with the first project.
Yeah, cool. Adam, do you have questions for Jared?
Yeah, I have one question. I noticed that as you were going through some of your data preparation, you said that you decided to bin your polar coordinates. And I'm curious if there was a specific metric that you were using to determine the bins and sort of how you went through that process.
I want to say with all of my bins, I use Q-cut, which would divide it into equal bins in itself. And then from that, I recorded what those bins actually were, and then set all the bins for the train, test, and validate into those values that was selected from the Q-cut.
Okay, so the bins of your location data weren't necessarily associated with specific physical locations. It was more just like separating the coordinates into bins of equal size.
Yeah, and I have zero idea on how to interpret polar coordination coordinates.
Okay, thank you.
Awesome. Thanks, Jared. Appreciate it. Well done. Up next, we have Joshua. And Joshua, on your GitHub, it's the model, or is it final report?
Final report.ipynd.
All right, cool.
The model is probably more interesting than this notebook's going to be.
I just noticed the two possible titles as you have for this project. Yes.
Yeah, it was difficult to decide which one was going to be more descriptive or more accurate.
I see. All right. I'm ready on my end. I think Adam's ready on his. Cool. So whenever you're ready to get started, go ahead.
All right. Hello, everyone. My name is Joshua Mays. This is going to be my report on the project for clustering on Zillow. I start off with some housekeeping, how to reproduce, and how to follow along with this notebook. And then I get pretty much directly into, well, actually, before we get in there, I want to go over the goals. I like the idea of agile story formats. If you aren't familiar with agile, it's a framework for getting work done in an organization. And they dictate, like, as a persona, I want this thing so that I can do this thing. What I came up for with this project was, as a real estate listing website, I want predictions on my model's log error so that I can reduce my model's log error. I just think that's an interesting way to think about it, and it's helpful for me to keep myself focused and understanding what my goal is. So getting into the executive summary, I wasn't really able to find very strong correlations to log error across any of the features that are existing in the data set. And as a result, I wasn't really able to come up with much. I made a lot of models, and none of them really beat the baseline. Some of them, actually a lot of them, performed worse than the baseline did. I needed to do something against the validate test set because of the rubric. It was supposed to be, did I skip over? I did, sorry, I'm disorganized today. My recommendation, if I were an employee working on this project, I would recommend that they hand this project off to somebody else. I did my best, I came up with nothing, and I'm not very confident that I'm going to come up with something given more time. Anything meaningful anyway. Another possible way to accomplish that is maybe posting a bounty on Kaggle and seeing if the data science community can come up with something. During my exploration, I did make some clusters, and I found actually some interesting clusters. I wanted to walk through them with you today. But before we get into that, I was able to make this chart. I don't know what to make out of it. It has a very nice curvy relationship when I engineer a feature and plot it against another feature that's related to it. I expect a straight line that divides the white space from the blue space, but it's a curvy line. It was just something that's interesting, maybe something that's meaningful, but I was unable to make anything out of it. The first cluster that I went to was a 2-feature cluster against the age of a property and its overall tax value. And I can show you how those clusters look when they plot against each other. With an ANOVA test, we're able to actually reject the null hypothesis that there's no variance. And the chart, when we take each cluster and plot the average mean of log error for each cluster, you can see that there is actually quite some significance between each cluster. I was hoping that that would translate into some better performance in my models, but that was not the case. The second cluster that I did, it's a little bit harder to show you how it divides in the data set, but it's the area, the latitude and longitude, and the age and the tax of how old the property is and how expensive the property is. Same thing. Actually, the cluster 2 here was the most exciting to me because it's right at 0. I thought that was going to be a powerful predictor. It was not. Again, clustering on location, this time just trying to capture the size of the property, both the structure and the land that it's built on. ANOVA, again, dictates that there's some variance there. However, it was not very predictive. So in conclusion, even though I was unable to glean any meaningful insights or create meaningful models, it wasn't because I wasn't trying. I did a lot of exploration, just nothing came through. If I were asked to continue work on this project, I would look at or start trying to collect data that's not included in this data set. Some things that maybe are available from other sources, such as market scores or something like that. I would also look at more sophisticated machine learning models that I don't have experience with, maybe like neural networks or maybe some other things that I'm not even aware that exist. The rest of the notebook is just documenting the collection process, the cleaning it up, all the decisions that I made through the various columns, pointing out some of the bad data that exists in the data set. And that is the end of my notebook.
Awesome. Thank you, Josh. I appreciate you with this Sisyphean task of attempting to find some value in these clusters. I know that it's challenging. I do think that the visualizations that I liked the most in this presentation were definitely just those simple bar plots. Really got across the idea that these are categories and the relationship of those categories to your target variable, which is log error. So I'd like to ask you a little bit, if you can scroll up to
the modeling.
Right, no, it's actually down right there. So we have this cluster that you've demonstrated based off of age and tax. And can you just walk me through why the cluster chart kind of looks the way that it does and the colors that it does, and why you think that perhaps that might not have been meaningful in identifying meaningful clusters with relations to log error?
So I think the cluster itself actually is meaningful. I think the biggest issue that I was running into when I was modeling is that all of the data is kind of concentrated around 0, and it's doing a very poor job of trying to deviate away from 0 when I'm using any linear model. The reason why these clusters are grouped this way is because of how k-means works. It tries to find an area around itself that kind of matches the mean distance between all of the centroids. I think that's how that works anyway.
Yeah, no, that's actually kind of what I was hoping that you'd say, that when we look at this cluster, so log error is not on this chart, so we can't necessarily see immediately from this chart how it relates to log error. But to me, this looks kind of like and this isn't, your fault, we asked you to do this. This is kind of like how k-means doesn't seem to be pulling anything meaningful out of this. Like it's sort of just subdividing it up into these different regions, and whether those regions have any real relationship with the target variable. I think the point that I'm trying to make here is that, and not just, I mean, for everyone that's in this classroom that's listening, is that a very clean looking cluster chart does not necessarily imply that there's any value to it. So we've seen a couple of times where I think students have demonstrated kind of messy looking charts or kind of clean looking charts. And there's sort of this, I think, this unconscious bias that the cleaner a chart looks, surely that must mean something, right? Well, no, we're just dividing up that domain space if we're using kind of a k-means clustering approach. What matters is how do each of those categories relate to log error, and that's where these visualizations actually, I think, were more meaningful than I think even just sort of well, how does it sort of pan out on a domain space? How does it divide up on a chart? And so that's kind of the point that I was making. So thank you for talking through that.
Yeah, thank you.
Adam, do you have any questions for Josh?
Yeah, I have one quick question. I noticed that when you were showing a chart of the evaluation of your different models, that most, if not all of them, were a random forest regressor of a different depth. And I'm wondering if you tried models other than the random forest.
I have a linear regression and a lessable R's. Neither of them use any features that weren't my clusters that I created.
Okay.
The reason why I stuck with random forest mostly was because I was unable to find a linear relationship. I was unable to find a polynomial relationship, and random forest is this very boxy, try to make it fit thing. And I thought that was probably the best chance of actually getting some meaningful results.
Okay, thank you.
Yeah, thanks. Appreciate it. Appreciate all the hard work. So up next, we have Daniel.
Hello, good afternoon. Let's see. All right. Can everybody see this? Can everyone hear me?
We can hear you. We can see you. I'm having a little bit of trouble pulling up your Zillow link. That's just give me one second.
Okay.
Yeah, I think it's just the way that it's formatted in Google Classroom, but
Gotcha.
see if I can get it up. Yeah, I'll pull it up later. And once you finish your presentation, if you could take a look at that and see if
Yeah, absolutely.
fixed. Awesome.
Um,
Okay. I'm ready whenever you are.
Cool. All right. So Zillow, what's the deal with log error? These are all the things I imported to use, all the tools I imported. Basically, I was just trying to figure out what was the cause of log error. So I started by cleaning up and acquiring from Zillow database on the CodeUp server. Total observations collected were 52,319. For cleaning and preparation, I dropped nulls, I dropped duplicate values, I dropped duplicate columns, ID columns, and after doing some correlation testing, just other columns that weren't deemed significant. Then I optimized the data by converting select columns and data types. For fireplace, garage total square feet, has hot tub, pool count, and tax delinquency flag. I felt pretty comfortable filling those with zeros for the null values, just because looking on averages for that area kind of showed that the averages lined up in our data with the amount of garages that people had or the fireplaces that people had. Some people don't have fireplaces, some people don't have pools. So after cleaning all of that, I came up with 51,728 observations. I did not end up, what's the word? Sorry. Totally lost my train of thought. I did not remove any outliers. I kind of went back and forth on that. But after using the IQR method, and I couldn't get my code quite to work for a couple other methods, it was removing about half the data, and I didn't really like that. So I just decided to keep it and see how it went. Then I split the data, train, validate, and test. I made more databases for the train scaled, validate scaled, and test scaled. And this is just a function to add the clusters that I've made earlier. So for exploration, here's the distribution of the log error. It's pretty standard, straight down the middle. Now for the correlations, I kind of just use this to pick my my features: bathroom count, square feet, full bathroom count, bedroom count, longitude, tax value by square foot, garage count, and latitude were among the highest. I think garage total square feet coming in close, but really there wasn't a ton of correlation with any of them. So I did bedrooms and bathrooms, visualize, and I'm actually a little bit happy that I didn't immediately drop the outliers, because it showed that the more bedrooms and bathrooms there was generally a higher correlation with log error. And on to clustering, I decided to do a bed and bathroom cluster, just into a low amount of bedrooms, high and medium. I kind of messed up on the labeling there, so ignore that. And then I did do a one-way ANOVA just to test the statistical significance of that. There was some statistical significance, so I thought that was good. Next, I did bedrooms, bathrooms, and square footage, just to add on that. Did a test for that as well. That also had some statistical significance. So I decided to use this one as well. Then I did latitude and longitude clusters. In some testing outside of here, I thought that cluster 4 had the best statistical significance. So that is the one that I'm going with. The one right here up in top. So my takeaway from that is that all these models did have enough significance that I feel comfortable using these features. I did also add one more feature. It's a bed and bath with tax value per square foot, just kind of meshing everything else in there. Then I split the baseline. I split all my features into dummies, and then I put them to work. So we got the baseline model, and then we calculated RMSE. So our RMSE was for train 0.177 and for validate 0.182. So first I started off with an OLS model, and that did just a little bit better on train and just a little bit better on validate. Went for polynomial and about the same. Did just a hair better. And so I went with lasso Lars, and honestly, they're all not great models. They hit the baseline, which is good. But what I was, won't say confused about was, or what I found particularly interesting was that lasso Lars was basically right on top of the train and the validate. I decided to go with that one. And it did do better. It did about 13% better than the baseline, but I'm a little skeptical on that, in that it could just be overfitting to the baseline. So my takeaway is that while it may work, there needs to be more exploration for it, and we probably need to gather more data. We're obviously missing something. So for next steps, more feature engineering, find a good method to handle outliers, or use a robust scaling model. Yeah, and that's it. Any questions?
Awesome. Thank you, Daniel. Yeah, very well explained from start to finish. I really appreciate that you took us through the data science pipeline as part of your presentation itself. Adam, do you have any questions for Daniel?
Yeah, I just have one question. I think it was the first visualization in your Explorer section where you were showing the correlation between every feature and log error. Yes.
Yes.
And my question here is, what statistical test are you using to determine correlation? And do you think it's appropriate for every feature?
So I used this as my code for this, and basically it was just getting the absolute value of all those features and correlating them to the log error, and then sorting by ascending, and then making a heat map off of that. I went back and forth with using that one and just a regular heat map, and honestly, it kind of pulled up about the same information that a normal heat map would pull up. That one just looks cleaner. So that's really all that was to, I mean, it's all potatoes. So I was just trying to, narrow it down.
Okay, thank you.
Yeah, Daniel, if you could go down to your modeling section really quickly. I have some questions about your metric of choice. So you used root mean squared error, which I think is an appropriate metric. And when you came to the kind of the final data frame that had all of your train and validate scores next to each other, you chose lasso Lars as the one to move forward with, even though polyregressor had a lower RMSE on both on both train and validate relative to lasso Lars. Can you talk to me through why you decided that lasso Lars would be the one that you would go with in the end?
You are 100% correct, and I was going to go with polyregressor. It was a bit late last night when I was going back and forth through them. And there was a specific reason I didn't use polyregressor and I liked lasso Lars better. I cannot remember that. Honestly.
Okay. I just wanted to double check.
Yeah. I remember testing through polyregressor a few times, and yeah, it just slipping my mind.
Yeah, and I appreciate your suspicion of even your test results where you're saying that, your model beat the baseline by 13.68, but it's still a little bit suspicious looking. I too would be a little bit suspect of how much of a performance increase we saw in train to validate the test, especially kind of knowing that at this point, probably your lasso Lars is almost identical to a baseline in terms of its actual coefficients and things that are being used. So it could just be luck.
Yeah.
Yep. And or we would need to dig deeper and find out what's going on with the test data frame, and how is that lasso Lars model really constructed, or to double check to see whether or not we should be safe using that number. Because I think that, yeah, you could go to a stakeholder and be like, I did it. And
but would it actually work?
right. And then maybe it doesn't work out so well for you in the long run. Cool. Yeah, Josh, you have a question. Go ahead.
Yeah, sorry to put you on the spot, Daniel.
Yeah.
But it looks like you didn't run baseline against your test data set. Is that right?
No, I guess I did not. No.
Right. I think that might be what's explaining the 13.68, because you're comparing it against two different data sets.
Yeah, that honestly could be it.
Yeah, I think that's a good, a good point. We've sort of talked about that with a couple of presentations that, in pristine ideal data science world, we only test it once. So I think that, Daniel, you're good on having only used your one best performing lasso Lars model on your test data frame. But then it also, to Josh's point, now we're sort of comparing apples to oranges. We're comparing the performance of a model on one sample versus a model on a different sample, and it becomes a little bit iffy on how much we should read into that difference. It's almost like it within the same sample on the same out of sample data set on validate, lasso Lars did not outperform the baseline. So I think that's also kind of worth wrapping our head around. But yeah, no, you did a great job. I think overall, excellent work.
Cool. Thank you.
All right. Up next, we have Luis.
All right, everyone hears me and sees my screen fine?
If you could zoom in just a little bit, I think that would help the laptop viewers in the audience.
Totally. $125, cool.
And also, Luis, I don't see the link to your work in Google Classroom.
Let me check that for you. My apologies.
You can always just, if you want, just copy paste your GitHub into like Zoom chat or something, and I can take from there.
I'll do that.
And then afterwards, update that. Cool, thank you.
Cool, no problem. Sorry about that. Okay, all right. Welcome everyone. I'm Moose Arcee. This is my Zillow clustering project. So going ahead, these are all the imports that I'll be doing. The goal of this is to uncover the drivers of error. What the drivers of error are in the Zillow Zestimate. We're going to continue to use the 2017 property and predictions value for the single family homes. To isolate what single family homes means, I capped it at 6 bedrooms and 6 bathrooms. I feel like that was pretty sufficient. So we're going through the acquire. All the normal acquire steps are here. Started with shape and columns. We're going to do a little prep work. We created the age column. I'm going to establish my X and Y variables, handle the latitude and longitude over here. We're going to take care of the outliers. I did this by using the IQR approach with a K equals of 3. Cool. And let's go into exploration. So to take you very quickly through the exploration phase, I did univariate and then the multivariates variables. For the univariates, we discovered that pretty much a lot of the variables used are normally distributed, and these following variables, tax value, all the various tax amounts and tax stuff are skewed to the right. We're going to look at the multivariate variables next. Tax amount in square feet get overestimated as it decreases in value, and then log error seems to increase after the 1940s. We're going to continue to explore our variables, and then we do a correlation map to see which variables are correlated. Over here, you see bathroom count, all the normal suspects calculated as finished square feet are highly correlated with log error. So these are takeaways. Higher tax amounts seem to have a lower rate of log error and probably should bin the age variables. And then according to the heat map, finished square feet was the feature that showed the most impact on log errors. So we'll go into the questions. Does county have an effect on log error? Graph shows that older homes seem to be primarily be in LA County, but as far as log error, it doesn't seem so from this map. Going on to question 2. Square feet and log error, is there a correlation? Yeah, this seems to be a smaller homes have a higher log error for sure. And as home size increases, the log error decreases, suggesting some sort of correlation. On to question 3. This is where we see from the 1940s on, there seems to be a bigger increase on both ends of the log error scale. But we're going to put it through a Levine test to test for equal variance. Variance is so not equal. So we're going to do a t-test to sample 1 and set it to false, and of course reject null hypothesis. Okay, and then we're going to check through question 4. I'm going to speed through a little bit of this, but basically we're going to take through a Pearson's test, and we will discover that we have to reject our null hypothesis, and bath count is super correlated with home value. So we're going to put through some clusters. These are all the elbows for all these clusters, just to take you through. They're all going to be pretty much a cluster of 3. And all these clusters don't really have too much. They're not very great clusters. They seem to be divided along certain lines, just kind of ambiguous centroids throughout there. And as Kevin pointed out, that I noticed too, is that this thing is clustered by the Southern LA County. Regardless though, I'm going to choose to take one of the clusters. Cluster area tax mean is one of the clusters that I'm going to choose to use as my feature. We're going to build some models for this. I'm going to create my Dunning variables and take you through. This is our baseline of 0.0159. And I chose to do something I like to call an advanced baseline. It's just a simple linear regression based off of the age variable. I'm also going to do a linear regression with a recursive first feature exclusion, and then KNN And these are all the features I got, or all the results I got. As we can see, RMSE is best for right now among KNN. But we will see here when it comes to the validate stage that the multi-regression validate does fairly well against the baseline. And when we move into tests, we're going to see that multi-regression actually beats the baseline by a little bit. If I had more time, I would choose to bend the age columns and remove more outliers to fine tune the model. Thank you for the presentation and welcome any questions.
Yeah, good job. I like what I see. I think that you put together a solid project kind of from start to finish here. I know that, yeah, the other day you were saying like, what's going on? But this seems like you knew what was going on the whole time. So you're doing good. Very good.
Thank you.
Adam, do you have any specific questions for Luis?
Yeah, I guess it's a similar one that I asked in a previous presentation, but I would like to see the correlation chart that you set up during Explore. And I'd like to dig into that one a little bit.
The heat map correlation?
Yeah.
Yes.
Okay, so I would just like to ask you, when you're running a correlation like this, what test is being used to determine the correlation between these features?
I'm not sure right now. It's just I just chose to do a heat map with a correlation on train sample, but I'll have to get back to you on that.
Okay, no worries. Yeah, no, I kind of put you on the spot there. And then follow-up question. I feel like most of the features in here look okay. I'm a little curious why building quality type ID is included in this feature here.
That one I should have chose to drop. It was only featured in LA County too. And I probably should drop that one. That one stayed on just because I missed it. But yeah, it was only indicative of LA County specifically. But yeah.
Okay, thank you.
Thank you.
Yeah, I have a quick question. Earlier in the discussion, I guess it was probably question number 2 in your exploration section where you asked, is there a relationship between square feet and log error? One of the takeaways that you noted was as home size increases, log error decreases, suggesting some sort of correlation. Can you describe to me what you mean by log error decreasing?
I guess log error on a whole doesn't decrease, but there seems to be less noise as the square feet increases.
Okay. Yeah, I think that probably, if I were to make a guess as to almost kind of what you were describing, is that the absolute value of log error seems to be decreasing in such that the distance from zero that's kind of represented by the bulk of the data is getting smaller and smaller and smaller. So we still have the log error increasing or decreasing is kind of a little bit of a vague term. As calculated finished square feet sort of increases, it seems like log error, if we were to just think of log error as like mean log error or the trend of the log error, it's still centered around zero. So it's neither decreasing nor increasing. But the kind of the absolute value of the log error, in a sense, does seem to be going down. Because if we look at it as not that negative or positive relationship, but sort of this cone that's sort of being formed, then I understand what you're saying. So I think that, my recommendation on that one is to be cautious about some of the terms that are being used here, since log error is not necessarily decreasing, and I don't know if necessarily we'd even see a correlation or a linear correlation that comes out of this data, because chances are
just going to go straight through.
Yeah, it's kind of Yeah.
Yeah.
It's hard to say that as square feet goes up, log error goes more negative or more positive, which is really what correlation would be implying. And instead it's like as square footage goes up, log error is still kind of around 0. It's sort of like a little bit more of a kind of an more advanced interpretation of the chart.
I understand. I'll watch my wording with it.
No, yeah, but good job overall. Thank you.
Thank you.
All right, and up next we have Jared.
Alrighty, everybody able to hear and see my screen? Fine.
Yep, looking good.
All right.
Just give me 1 second. I'm still haven't pulled up your report. Okay, great. I'm ready whenever you are.
Alrighty, my name is Jared Jones, and I'm here to talk about what factors contribute to log error. The goal of this project is to identify drivers to help determine the log error of a price of a single family properties by constructing a machine learning regression model with features from clustering. The description, basically, the gist of it is home buyers are looking for homes and they're using Zillow as a way to shop for their future home. And the one thing that helps determine a buyer's decision to look at the home is, of course, the features of the home, but also Zillow's estimate for that home. And to give you more information about log error pertaining to Zillow's data is the log of Zillow's home estimate minus the log of the sell price of the home. This is the data dictionary and acquisition from SQL, from CodeUp's SQL. And it's a raw data set. It I brought in 54,000 rows and 67 columns, and there was plenty of null values. After doing a lot of investigation to try to fill in those values, I realized that a lot of the missing values are just from possibly missing input in regard to they didn't notice the feature, they just left it blank instead of putting 0 or another value inside that field. So what I did was I filled the majority of the values in columns that was simple, like, does it have a fireplace with 0 or has a pool, and did some other conditions to fill in those values also. After I refined the data set, I came to 52,000 rows and 40 columns. And I split the the data set into 3 subsamples by county, which is by LA County, Ventura County, and Orange County. And here are the shape of those samples of the whole data set. And what I did was I created a function to basically zero in on one particular county. And that first county I was going to do was going to be the LA County's data set. And I scaled the data using a min-max scaler. And I forgot to add, while doing my exploration, also I did remove outliers of extreme variables in regards to the number of bedrooms greater than 7, or square footage a certain amount, or the lot size was very extreme. I created clusters using 3. The first one was an area cluster with the K of 4. And the reason why I went K of 4, if looking at it, doing a range, it seems that the nice change occurs around 4. This one shows other ones, but I believe 4 is the best one. And I created another cluster called size cluster, which I went with the K of 6. And that one, once he got to 6, it did an abrupt jump. So I said, let me stick with that one versus going with 4 also. And the other cluster I created was a unique, even though it's categorical, is a tax due cluster, because I wanted to know if the log error was impacted by if a home was delinquent on its taxes. That was one thing I think would impact the value of a home. And with that, I got the K of 3, and from here it's in between. And if I look here more exact, it's right there, but I probably show history right here. And our last one I did was a price cluster, and with a K of 5, and looking at the chart for this, it seemed like 5 would have been the best option to go with, also with the changes. Then I created dummies for those clusters inside my data frame. Unfortunately, I got too far into exploring my data and trying to save most of the data I wasn't able to get to my modeling phase. But I would have continued using the models from the previous project to see how well my clusters will perform and with my models. And in regards to recommendations, I would recommend that Zillow should go through and re-enter all null values with its correct data. And that's it.
Awesome. Thank you, Jared. Appreciate it. I guess I have a question. Once you had identified so you made the clusters, I don't see necessarily where we really kind of explored them in depth. Did you get to the point where you were able to maybe use some kind of feature selection process or anything like that to identify which clusters might have value?
I did not get to that part yet. That was gonna be the next thing I was gonna do after moving on to modeling, was gonna determine which features would be best to utilize. But I would like to utilize some of my clusters and some of my models also to see how well they perform.
Okay. And so that's something that maybe if you had more time, you'd have been able to get to.
That's correct. And better time management, doing the data cleanup, basically.
Gotcha. Adam, do you have any questions for Jared?
Yeah, I have one question. Towards the beginning of your notebook, you had 4 great questions that you were asking of your data. And I'm wondering if those got answered at some point in your notebook.
I did not do any statistical testing with those particular variables, but I did in my actual workbook, I plotted them just to see how they look. And I did notice there was some possible correlation with each thing. Prime example would be the county. That's one thing where the home was located at. There seems to be a difference between log area. It wasn't constant across the board when doing a distribution chart. The other thing was tax delinquency. I noticed that it was either yay or nay. It wasn't a true I couldn't tell if it was really a true relationship towards that. And another thing also that I did notice that I didn't include was I noticed that the log error was greater. The difference was greater from 0, either negative or positive, depending on if the bedrooms was less than the bathrooms. Like there was a weird situation, or if when scaling the lots and the square footage of the home, there was also a difference of the log error also. So it was a lot of things that I noticed while just doing it, but I didn't actually do the statistical testing.
Okay, awesome. Thank
And that
you.
was
I
just
think-
in one county. It wasn't even in the other 2 counties of the overall data set.
Okay, that sounds like great exploration. Thank you.
All right, everyone, that's it for today. We will have one, at least one more presentation later, probably later in the week, kind of randomly, depending on when Saruj starts feeling a little bit better. But I appreciate everyone's hard work. I know that this is a challenging project, kind of a race to the finish. And then on top of that, you were also asked to get your presentations down to this very, very, very short time period. And I would encourage you, we're going to have these recordings and we'll go ahead and post them. So if you want to look back at your own presentation to kind of evaluate your own performance, that's something that is always a good idea to do, unless it's just too cringy to endure. But I would encourage you to look back at your own performance and also consider the presentations that others have made today. And if you saw something that you liked or a way of approaching how to kind of move through a project very quickly, just borrow that sort of that style or that way of approaching these types of discussions. We'll just go to lunch just a few minutes early. And when we come back from lunch, we'll do a quick little retrospective assignment on this project, and then we'll move on further into the curriculum. So go ahead and take a deep breath and relax for the next hour or so.